Hello, I am Lakshmi Dikshita from CSC department. I am explaining my topic. The topic is DQ with different types of DQ with examples. DQ on different types of DQ with examples. Introduction to DQ. A DQ is also known as double-ended DQ. A DQ is a data structure that allows insertion deletion of elements from both ends. It combines the properties of both stack and queues, making it versatile for various applications. DQs can be implemented using arrays or linked lists, giving them dynamic sizing capabilities. Basic operations on DQ. The primary operations on DQ includes insertion, deletion, and peeking at the elements. Elements can be added or removed from either of the front or from the rear of DQ. These operations typically have a time complexity of O of 1, making them efficient for real-time applications. Types of DQ. There are two main types of DQs: input restricted and output restricted DQ. An input restricted DQ allows insertion only at the end but allows deletion from the both ends. Conversely, an output restricted DQ allows deletion only from one end while permitting insertion at both ends. Input restricted DQ. An input restricted DQ allows elements to be inserted only at the rear. This structure is useful in scenarios where data needs to be processed in the order it was added but only allows removals from both ends. This structure is useful in scenarios where data needs to be processed in the order it was added but only allows removal from the both ends. A practical example is a ticket queue, where new tickets can be added at the back but tickets can be served from either end. Output restricted DQ. An output restricted DQ is a scenario like a buffer where new data can added from either side but processing must occur in the specific order. A common example is print queue, where documents can be added from different sources but must be printed in order they were received. Circular DQ. A circular DQ is an advanced type of DQ where the last position is connected back to the first portion. This structure helps in efficiency utilizing memory as it allows for continuous use of the array without shifting elements. An example use case include a round-robin scheduling algorithm in operating systems where processing are managed in a circular fashion. Applications of DQ. DQs are widely used in implementing algorithms for scheduling and resources management. They are also useful in scenarios where both LIFO and FIFO operations are needed, like managing a playlist of songs. Additionally, DQ can help in solving problems like palindrome checking and in maintaining a sliding window of elements. Additionally, DQ can help in solving problems like palindrome checking and in maintaining a sliding window operations. DQ implementation in Python. Python provides a built-in module called collections that includes a DQ class. This class allows for easy creation and manipulation of DQs with methods like append left, pop and pop left. For example, from collections input DQ creates a DQ that can be used to manage data efficiently. Performance considerations. Time complexity for adding and removing elements from either end of DQ is O of 1. However, accessing elements in DQ can take O of n time if structure is not implemented in a specific way. Choosing the right type of DQ based on the application can optimize performance and resource usage. Choosing the right type of DQ based on the application can optimize performance and resource usage. Conclusion. DQs are performed data structures that can support flexible and efficient data management. Understanding the various types of DQ and applications is circular for developers. Their versatility makes them a valuable tool in both academic and practical programming scenarios. Feel free to expand upon any of slide or modify them to suit your needs. Feel free to expand upon any of the slides or modify them to suit your needs. Thank you.